Good afternoon, everyone. My name is Ngamini, and today I'll be telling you all about my love for NLP. The other name for my presentation is Melissa in NLP Land. So my presentation is going to be straightforward. At first, I'm going to tell you a little bit about myself, how I fell in love with NLP, and I give you 3 data stories that I was able to tell using data. And hopefully at the end, we're going to have time for questions and answers. My name, of course, I have this, my name, and I have a pretty strong mathematical background. I have a bachelor's in mathematics from Morgan State University in Baltimore, Maryland. And I got my PhD in applied mathematics from North Carolina State University in 2015. I am currently working as a data scientist at ADP, a lead data scientist at ADP. My career has been very long so far, I think, and I've enjoyed everything that I have done. I was first a math professor at Morehouse College in Atlanta, where I was able to work on different machine learning projects with my student. One of my students wanted to be able to predict the stock market. We did that using supervector machine. Another student wanted to be able to determine the likelihood that a veteran will develop PTSD. And we were able to do that using classification, using random forest. After that, I decided to transfer into the corporate world. And my first job was at Warner Media as a data scientist, where I had the chance to work on projects that had to do with NLP and not NLP related, but it was all fun to me. I currently work or volunteer for an organization called Athletics, where I am the head of education. This is a program where we are coming together to help the most vulnerable and underrepresented communities gain economic independence through a data analytics bootcamp. And I'm currently working as a lead data scientist, as I said before, at ADP. And I've been so lucky that most of my work has only been NLP related work. So how did I fall in love with NLP? Really, that happened when I was learning all about data science and the different machine learning techniques they are out there. So first you have supervised learning, where in the mathematical world, you will call it, you know the why, you know the outcome you are trying to predict. You have regression problems where you want to be able to predict the price of the house. You have classification problem where you will be able to see if a customer, the score is a poor score, fair score, or excellent. Now you go into unsupervised learning, where in unsupervised learning, we do not know the outcome. We don't actually know what's going on with the data set, and we want to gather insights from it. Now, one of the main ways to do that is by using clustering technique, where you want to look at your customer and put them in different segments. And then you get into natural language processing. And this is where I fell in love, because I was like, wow, so there is a way here that we can use word. And why this was important to me was because when I was doing my PhD in applied mathematics, I was all impregnated in the STEM world. And I was writing a fan fiction as a hobby, and that allowed me to have my creative side still alive. So here then in the data world, I was able to find a place where both of them came together, right? Now, this also really happened if you look at the personal project that I worked on, right? At first, I wanted to predict how late a flight will be, predict available listing in Seattle Airbnb. But then as soon as I realized that NLP existed and there were words, I was like, this is it. All my project became all about word. I wanted to be able to predict the artist name just looking at the lyrics. I wanted to know what the article is about, just looking at the content, and then wanted to recommend hotel based on their reviews, ratings, and their location. So everything became all about words for me. Now, after this, then I want to now kind of tell you a little bit about the first story, right? If you wanted to know about the 2016 election without reading a single article. Now, the goal for this project was really to figure out what's going on in the article without having to read a single article. And I was thinking that, for this kind of project, a possible client will be a media company, a news publication, or a blogger. Now, all my data set was gathered from Kaggle, the 50,000 news article, and I created my topic model using latent semantic analysis. And after that, the topic prediction or topic classification was done using stochastic gradient descent. Now, if I go further here is the results for my my 10 classification model. So you have all the different topics that I found here. But here I wanted to go further into topic 9, for instance. How did I come up with the name of for this topic? So when you look at the topic itself, you see that police, attack, and border are more recurring in this topic 9. Now, also what I had to do is go in and kind of read some of the articles there and try to understand what they were about. And then that's why I name it fear mongering against immigrant. But basically for all those articles here, this is what I had to do. I had to put them together in a class and then go in and figure out what they were talking about. Now, my next story, funny enough, is also about elections in a sense, because at this point I got hired at Warner Media, and my first real project was all about Twitter bots. Basically, we wanted to be able to look at users on Twitter and be able to figure out the probability that one of them is a bot or is not a bot. Then after we do that, we then want to create a network where we understand how the bots interact with each other and with other users, and then figure out what are the top 5 things that the bot are trying to push at a particular moment. The client here is a major news network, and our data was basically pulled every day from 8 a.m. to 8 p.m. From Twitter. Now, for the likelihood of the propensity model for the bot was built using gradient boosting, and the topic model after that, when we got the network, was done using latent Dirichlet allocation. Now, here is one network that we have here. This network was based off of the impeachment hashtag on the period of October 4 to October 13, 2019. Now, you have a lot of dots here that you cannot see very clearly, but really the yellow color means you have a low probability of being a bot. The high green color means you have a high probability of being a bot. And the pink over here is a reply, and the blue is a quote. Now, for this particular network on this particular period of time, here is basically what the bots were trying to push. Over here, you see on the first one, you have here a mention of Jimmy Carter. That's because at the time, the past president Jimmy Carter had said something about the then president Donald Trump, so bots were trying to say something about it. Also, during this period of time, there was an ambassador who was presenting or reporting to the Senate, and of course, the bots were trying to say something about it. So now, another thing that was really interesting here was that when we are trying to build this bot model, and we realized that sometimes the bot, the people, regular users, will behave like bots just because of how they behave in a particular hashtag during a particular moment of time. So that's why what we had to do at one point was basically look at users, and if you have a blue check mark, we just have to give you automatically a probability of 0. If not, you will be able to consider like a bot. For instance, you have this user here who pretty much is behaving like a bot, but at this moment during this hashtag, but this is a regular person. You also have here the then President Donald Trump also behaving like that, but he's a regular person. And the Senator Adam Schiff over here also behaving like a bot, but really being a regular user. So this was a very fun project, and I had a lot of fun working on it and learning the stories that were being pushed during that time on Twitter. Now, I currently work for ADP, which is a human capital management company. So we have now different sets of rules or different stories that we are trying to tell. Now, at this point, it's like if a customer comes to our chatbot, can we determine quickly what they are looking for, right? So here the goal is to quickly determine the customer intent, right, when they interact with the chatbot. And the client here is the payroll team. Now, I want to stop to kind of give an explanation, right? What is the difference between topic classification and topic modeling? In topic modeling, basically, it's an unsupervised learning problem. You don't know what the different clusters are. You have to cluster the utterances together, the tweets together, the documents together to figure out what is the main topic they're trying to push. With topic classification, you actually already know what the topic is. We know they want to call about taxes, about the paperless, deactivation, things like that. We already know those things. We just want to be able to quickly predict those, quickly know what they are talking about. Here, the data source are chatbot utterances. The topic classifiers, we had multiple topic classifier we created. The BERT model, which is a transformer model, the CNN model, which is a classic neural net. And then what actually worked the best for us at the end was the mixed model, which is a combination of the two. And I'm going to go ahead here on the side and tell you more about that. So now the BERT 80, that's what I'm going to call this model actually, is because it only covered 80 classes, right? And then you have green, meaning that for this class is very high accuracy, yellow means is mid-level accuracy, and then red is low. Now, what is great about the BERT model is that, it does well for things that have, for topics that have a small distance between them. What do I mean by that? It means that, they are kind of intersected. So for instance, if you look at payroll schedule and void payroll, right? When somebody will type a message about payroll schedule, it will sometimes have something to do with voiding a schedule, right? And when somebody will come and type a message about void payroll, sometimes it will have to do with payroll scheduling too. So those topics have a small distance between them. And also those topics have usually very long writings. So that's why the BERT model is good here, because it has semantic understanding. Now, I also want to mention the black, which is in the unclear and other. Those over here are topics that the SMEs at the time couldn't place yet in a category or hadn't created a category for it. So they put them there. But in the BERT 80, this topic were not represented. Now, the next model is the CNN 45. Okay, 45 because it only covers 45 topics. For this one over here, what is interesting is that we had to make it so that it had only 50 utterances per topic. The BERT model doesn't have to have this restriction. You can have 5 utterances in one topic. Now, the CNN models will do well with topics that have a large distance between them, meaning they do not intersect. So representative, right? Someone that is typing message representative, they don't even want to interact with the bot, they just want someone to come talk to them. Now, somebody calling about amendment or garnishment, it has nothing to do with payroll schedule, right? If you're talking about amendment or garnishment, it has nothing to do with those things. So that's why we call a greater distance between them. And also, he really liked things that had short to the point sentences. That will do well with the CNN 45. And now the mixed model, which is the combination of the two. Now, what happened is that now with this model, it will just take, so for instance, technical issue does very well with CNN 45. That's what it's going to use to predict. Payroll schedule does well with BERT 80. So that's what I'm going to predict. So, and that was able to improve our accuracy. So the BERT model was at a 73% accuracy. The CNN was at 70%, but the mixed model, when mixed them together, you get 84% accuracy. So I was able to tell so many stories this way, and I had fun, just talking about, going through this project. And here is my love story about NLP.